These are the commonly used metric prefixes that we'll use in Chem 9, and we'll use them all semester. Now normally it's helpful to have some of these memorized, and maybe you already have, but you can always use this worksheet, you can use your lecture notes, you can use the Chem 9 cheat sheet. But the thing to know is that the symbol, such as this one at the top is an uppercase T, is tera, and that's a prefix that will be attached to a unit, such as a terameter, which would be a TM. So this unit is going to be on the right side of the prefix. Okay, and so this is the symbol is equal to a power of 10. So tera is 10 to the 12. So if you have a terabyte of data on a storage for your computer, that's 10 to the 12 bytes. Okay, so each of these are prefixes: giga, mega, kilo, hecto, deca. So those are greater than the base unit of 1, and these prefixes are less than the base unit of 1. So these are still prefixes: deci, centi, milli, micro, nano, pico, and femto. And so you should notice these symbols, the majority of these symbols that are greater than the base unit of 1 are uppercase, so the tera, the giga, the mega. But there's also, this is deca, and that's a DA, it's 2 letters. So these symbols that are less than the base unit of 1, these are in the fractional, so they're not negative, but they're fractional, like 0.1 or 0.01. This is in the scientific notation equal to, so deci is 10 to the minus 1, which would be 0.1. Or C is centi, which is 10 to the minus 2, which would be 0.01. Okay, and so these are lowercase values, lowercase letters when it's less than the base of 1. But this is the symbol, it's a Greek symbol, micro, and it looks like this sometimes when I write it, and that is 10 to the minus 6. Okay, these are also in Appendix 1 in the back of the book of the Chemistry in Context ebook textbook. So for metric prefix conversions, you need to set up a conversion factor using the starting point of the metric prefix. So kilo, for example, is K, and that's 10 to the third. Or hecto is H, and that's 10 squared. Deca is DA, and that's 10 to the first. So those are greater than the basic unit of 1. Now when you get smaller than the basic unit of 1, you have deci, which is 10 to the minus 1, centi, 10 to the minus 2, or milli, that's 10 to the minus 3. And these would also usually have a unit associated with it, like a decimeter, or a deciliter, or a decigram. So those are all the units, the M, the L, and the G. Okay, so these metric prefixes are used in conjunction with units of measurement. So when you see a problem like this that says express 1 meter in terms of dm, cm, and mm, these are metric prefixes. So D is deci, that's 10 to the minus 1. C is centi, that's 10 to the minus 2. And M is, lowercase m is milli, that's 10 to the minus 3. So when you're looking at 1 meter, so 1 meter, that has to have 10 to the 1 decimeters. So this is 1 meter has 10 squared centimeters, and 1 meter has 10 to the third millimeters. Okay, so those are for the base value of 1. You have to have more that the opposite, the reverse value of that in the exponent. So this is 1 meter in terms of decameter, hectometer, and kilometer. So deca is 10 to the 1. Hecto is 10 squared, and kilo is 10 to the third. So those are greater than the base unit. And so when you have 1 meter of that, that's going to be 10 to the minus 1 of the decameters. Or 1 meter of the hectometers, 10 to the minus 2 of the hectometers. And 1 meter of the kilometers is 10 to the minus 3 of the kilometers. So let's look at one of these examples in setting up a conversion using a metric prefix. And this is starting with the metric prefix symbol, setting up a conversion factor. Okay, so for example, D is deci, that's 10 to the minus 1. If I want it to be a decimeter, I need to multiply m meters onto both sides of this. So decimeter equals 10 to the minus 1 meter. When I put a 1 in the front, this is multiplying anything by 1 can be done. So now you've got the 1 decimeter equals 10 to the minus 1 meter. So you might have been puzzled, how did I get to this 1 meter equals 10 to the 1 decimeter? So here's how that worked, is if I want to make this 1 equal, figure out what 1 meter is, I need to divide both sides by 10 to the minus 1. Okay, and this is going to cancel out. 10 to the minus 1 will cancel out top and bottom, and I'll be left with, on this side, 1 meter. Okay, on this other side, I have 1 over 10 to the minus 1 decimeter. And remember, 1 over 10 to the minus 1, you could write instead 10 to the 0 for the 1 and 10 to the minus 1. 0 minus minus 1 is 2 negatives. When you subtract a negative, that's 1, or 10 to the 1. Okay, so this would be 1 meter is 10 to the 1 and decimeter. That's what I just did there. Okay.